finally we would say, wow, this thing that's eternal and uncaused is going to sound a lot like God. Now, most people will tell you in an argument of this nature, if you want to defeat this resulting conclusion, you start with the first premise. If I can knock this down, then this isn't true. And so the first question is, are we really in a universe that has a beginning? And some people would reject that claim. Now, we're going to talk about something right now called Big Bang Cosmology, and it's going to get everybody's kind of, underwear in a bunch. But let me just kind of work with you on this, okay? When I say the universe has a beginning, here's what I mean. It's a very important distinction. I mean that everything came from nothing. The universe is all space, time, and matter. That's what makes up the universe. Space, time, and matter. I'm here to tell you that everything, all space, time, and matter, has a beginning. That's what I mean. That's important, you're going to see in a minute. Because we're going to talk about Big Bang Cosmology. And for a lot of Christians, and I work with groups that are young Earth groups, or groups that are old Earth groups that would reject Big Bang, though. When they hear that word, oh, that's ridiculous. That's that non-Christian science. I reject Big Bang Cosmology. I want to just tell you what I'm offering here, the big thing about the Big Bang. When I say the Big Bang, here's what I mean. And here's what I don't mean. What I mean is that everything came from nothing. All space, time, and matter came from nothing. That's all I mean. That's all I'm trying to affirm by talking about the Big Bang. Here's what I'm not saying, okay? I'm not saying because I accept the Big Bang that I therefore accept the theory of evolution. I don't. They're two different theories. How things change over time, that's a different issue than how things began altogether. So you can reject evolution and still embrace the big thing about the Big Bang. Also, I'm not suggesting any particular age of the universe. Don't care what you think, how fast you think the universe was created. Don't care if you're 6 literal days. Don't care if you're 6 epic periods. I don't care. All of us agree on one thing, that everything came from nothing. Got it? That's the big thing about the Big Bang. So don't mistake me. Don't think because I believe that I can make a case for the Big Bang that I therefore accept some other view of science like the theory of evolution or a certain age for the universe. That's something you can still debate. But this is undebatable. The fact that everything came from nothing is a conclusion that science makes for us. Now, why I don't really get all uptight about the Big Bang is because if there was a Big Bang, that means there was probably a Big Banger. And that's the whole point. If there was a Big Bang, there's a Big Banger. And I'm offering that the Big Banger that's sufficient to cause the Big Bang has to be God, based on what science tells us. And let's talk about that for a minute. I want to give you a few pieces of evidence for the beginning of a universe that I think are pretty compelling. And they've been offered for probably now up close to 30 years in a very old book written by this guy, Robert Jastrow, called God and the Astronomers. It's a great book, by the way. You should get it. And it's a very simple, and it's, by the way, we've done this science over and over again. All the science he mentions in this book is still very valid. He gives 4 simple pieces of evidence to demonstrate that we are in a universe that has a beginning. Here's the first one. Second Law of Thermodynamics. Oh, please. We're going to do science? Yes, we're going to do a little bit of science. Here's the second law of thermodynamics. It's also known as the law of entropy. While a quantity of energy within a closed, isolated system like the universe remains the same, the amount of usable energy deteriorates gradually over time. In other words, disorder increases. Usable energy is lost, and disorganization and randomness and chaos increase. Things are wearing out. Things wear out over time. Is that really all that controversial? The reason why you and I die is because of the second law of thermodynamics. It's just the fact of the matter. The reason why things age and go from order to disorder is an issue with entropy. Let's put it this way. What if you walked in this room and you saw this? A wind-up toy. And it's still unwinding. What would you look for next? The winder. Why? Because you know this toy has still got some wind left in it. And if it still has some wind left in it, that means it wasn't wound all that long ago. Or it would have been unwound by now. So you're not only looking for a winder, you're looking, he's got to still be here because this just wound up a few minutes ago. If we're still in a universe that has wind left in it, could that universe be infinitely old? No, there'd be no wind in it anymore. There'd be no energy left in it if it was eternally old. The fact that there still is energy left in a universe in which there's the second law of thermodynamics means that we're in a universe that had a beginning in which this universe was tightly wound, and now it's unwinding. Does that make sense? So this points even referentially to a universe that has a beginning. How about the expansion of the universe? You realize we're in a universe that's expanding? And we know this both by mathematics and by observation. We can see it. Edwin Hubble, in his telescope, actually saw this. It's called redshift. The spectrum, the light spectrum shifts for those things that are moving away from us. And it shifts when those things are moving. If you view them through a telescope, the spectrograph of these elements will actually shift over time. Here's what I mean by that. If I've got a star that I'm looking at, or a galaxy, any object in space that I'm looking at, and it's moving away from my telescope, if I'm looking at this with a spectroscope, and I've got a star that's moving away or close, it's shifting in one direction or the other. The color spectrum. If it's coming toward me and I can see it, it'll shift toward blue. If it's moving away from me, the light spectrum shifts toward red. He actually looked in his telescope and saw that everything was shifting red. In other words, everything is moving away from us. And you might think, well, how can that be? Are we in the center of the universe? No. Imagine if we were on a balloon. Imagine if we were on a balloon here and I blew it up. And on the balloon, before I started blowing up, I drew little galaxies and stars. As this balloon grows in size, these stars and galaxies get further away from each other, right? And it turns out no matter where I am on the balloon, which galaxy I am, let's say I'm this galaxy, as the balloon gets bigger, these stars are moving away from me. But even if I'm over here, as the balloon gets bigger, this star appears to be moving away from me. No matter where you are, you get a redshift. Make sense? Doesn't mean we're in the center of the galaxy. But that redshift shows that we're in a universe that's expanding. Now imagine if I went backwards in this. What if the balloon is getting bigger, but now I ran it backwards in time? And I'm pulling the balloon back to the smallest possible balloon it could be. Do you see the problem? It means that we've got a point in the distant past from which everything was tightly bunched, tightly gathered, from which everything began to expand. Do you see the difference? That's why when we look at an expanding universe, we can have pretty good confidence that we are in a universe that had a beginning from which it expanded. Third piece, called radiation echo. Radiation echo. These are the two people who discovered it. They didn't really discover it on purpose. They discovered it by accident. They had this big instrument in the sky. They were listening to the stars, and they had all this background noise they couldn't get rid of. Here they are, a little bit older. This was 1978. They won the Nobel Prize for this. They asked a colleague, what do you think this is? We've tried to clean this. We think maybe it's bird poop. You know, birds are flying over all the time, so we clean this thing 1,000 times. We still get background noise. The colleague said, well, maybe it's not bird poop at all. Maybe what you're hearing is echo of radiation. In other words, you're hearing radiation in the universe that's uniform across the universe. So they launched a satellite called COBE, not the Laker, the actual satellite, Cosmic Background Explorer, and we now have taken pictures of this radiation in the universe. There is background radiation in our universe. What in the world is causing that? That's the question everybody has. Well, think about it for a second. We have something in law enforcement called a flashbang. We're not really smart when it comes to naming our tools, so we're pretty straightforward. What do you think flashbangs do? They flash and they bang. So if we've got a SWAT maneuver and we've got somebody barricaded in here and I'm barricaded in this corner and I've got a hostage, right? We'll throw a flashbang in through that window. And when it hits the ground, it's basically a sonic grenade. And it goes off. It is super, super crazy loud. And it's super, super crazy bright. It'll blind everyone in the room. It'll kick up so much debris and dust. You won't be able to hear anything for 5 minutes. It'll blow your ears. But it will definitely distract you. And the minute he sees that, we'll come in behind him. So we use it as a distraction device. And when we get it in the room, it takes about a minute for that room to cool down, and you can hear things again and see things again. It's so bright. This is what's happening in the universe, is we have a moment in the distant past from which everything begins to expand, and the leftover brightness in the room, the ringing in your ears, is the background radiation we're measuring, and we're seeing that radiation echo. That's the third piece of evidence. The radiation echo actually is still there. We see it. It's the leftover from that expansion moment. That's the best explanation for radiation echo.